Today we are going to see about what is OSI layer and IP addresses. Any small parts also there we will try, and if possible then some, because OSI layer is there, so we can also discuss about based on OSI layer how to troubleshoot the network also we can able to discuss. Okay. So learning of OSI layer is mainly two parts. One is like just what is OSI layer, what are the 7 layers, what are the each layer, what it will do, basics. And you want to learn about each layer in depth, so explanations and all, and comparison between the OSI layer and TCP IP layer, TCP UDP comparison. Okay, so like this, how many are there? So we'll how much we can try, we can try. Okay. So first of all, today first is OSI layers. What is OSI Open System Interconnect? OSI layer is a reference model. 1 second, I will close that door. Okay, so I think it is reduced. Okay, so lot of people think it is OSI layer. From OSI layer, different type of layers are came, like a TCP, IP, SPX kind of stuff. Is came from the OSI layer. Actually, no. Originally, the TCP IP is older than a OSI model. Okay. Next, even I heard she's already certified in so many CCNA kind of stuff. Okay, she got very that salary. Okay, so she told that it's like a trainer. The trainer told, even on I heard 2-3 times that like OSI layer is not generally we are not using OSI layer. The OSI layer is used by very big organizations, very rarely very big organizations, so only research and development only like that. So very sensitive, very big high processing places, only OSI layer is using. Guys, OSI layers, OSI model, not OSI layer, it is OSI model is a reference model. It is used to understand network and troubleshooting. Okay, so to understand a network, to create a network, to create a network or create a network model or troubleshoot a network is a used to troubleshoot a network. Okay, so only that part only. So OSI layer is used to understand all other layers, whatever the layer it is. We can use OSI layer to understand TCP/IP or Apple Talk or SPX, IPX, whatever it is. So people put a words, but we never see novel network. Okay, to understand that network functionalities, different network functionalities, we can use OSI layer as a reference, as a reference. So practically no one is using any OSI layers, but understanding network and understanding function of network, or create a network or to troubleshoot a network, to understand other models, or you want to create your new model, OSI layer is helpful. Sometimes misconceptions, misunderstanding, because of there are studied from some material, or maybe because of there are get the information from others, or to convey certain times an answer, then people put a to tell in some ways. So it can be a misunderstandings, like a star topology, mesh topology kind of stuff. Okay, star is different, mesh is different, right? Same way, it's a OSI layer. So open system interconnect. OSI is a reference model. It contains 7 layers. The OSI model contains 7 layers. That's why it is called a 7-layer model. OSI model used it to create, troubleshoot, understand a network. It is standardized by ISO, International Organization for Standardization. Okay, International Organization for Standardization, not an international standard organization. It is an international organization for standardization. So this organization told it is a standard model, so any person can understand and easily use for a purpose. Okay, so standard model. So different models will come by, but so only few are standard. Okay, so of course it's some different names are involved here. So some of them like IEEE is also done this research journals and all. So in 802 means it's February 1980. This it's a journal number it is. So all networking related follow this 802 means 802 standard model. So IEEE, I think you guys know already, Institute of Electrical and Electronics Engineering. So when you see RFC means it is a request for comment, means that's a lot of research is going on. People who put it, what is it will do, they'll put a comment or so how it is function here, or maybe what is this, like people do it. I guess it's in a research part. We don't involve in much. Okay, currently not required also. So again, what is OSI? Open System Interconnect. OSI is a reference model. 7 layers are there. That's why it is called as a 7-layer model. It is used to understand a network, to create a new network, or to troubleshoot the network in a layer-wise troubleshooting is there. You know, some people put in a resume OSI troubleshooting. There is no OSI troubleshooting. OSI layer-wise troubleshooting means like this. These are the 7 layers. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. We can understand a network from physical layer to application layer, or application layer to the physical layer, and any issues occur also we can understand by layer also we can understand, and we can do troubleshooting exactly where the issues occur. Okay, guys, again, these 7 layers, some people read from top to bottom, bottom to top. Okay, it means some people read like this: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. If you take certain textbooks, so it is given in this order. If you go to certain other textbooks, other materials or PPTs, okay, or some people from their background, like people read it like a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Which one is correct? Some people will confuse. So you have to go from the application layer to physical layer, or physical layer to application layer. Both are correct. Only one important thing is, do not change the do not interchange the layers. Means I started like a application layer, physical layer, session layer, network layer, transport layer, data link layer, session layer. Like do not interchange it, and do not forget any layers. 7. Please count the 7 numbers at least. Okay, and practice. How to remember? Just practice only. How can I remember? Because I practice, because I keep reading and keep telling to people. So I remember anytime I can able to tell. Okay, so it is like that. There is a few things you have to tell to the people, like anytime the people can able to speak about it. Okay, so application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. If you want, you can write in your hand or maybe write on just one paper. So when you put it in a mobile phone, keep reading, and by understanding you read, that's definitely it is stored in your mind easily. It is a 7-layer, guys. It is a 7 to 1 layers. It is 7th layer is application layer, 1 layer is physical layer. That's why some people read from the 1 to 7. Some people read from the 7 to 1. 1 second. Okay. Okay. Sorry. Here it is. Application. Okay. So that's you can read it from top to bottom or bottom to top. The first 3 layers means application layer, presentation layer, session layer all is called as a top layers or upper layers or software layers. Software layers. The bottom 3 means the network layer, data link layer, physical layer is called a bottom layers. Okay, top layers or bottom layers, upper layers or lower layers, right? So that kind of stuff will come, right? So first 3 layers, application, presentation, session is called a top layers or upper layers, and software layers. First 3 are software layers. Last 3 is a network, data link, and physical layers comes under bottom layers, or you can say lower layers. Lower layers are not there, so the word is not there. Bottom layer, top layer, bottom layer. Okay, bottom layer, and also called as a hardware layers. Why it is called as a hardware layers? Because of physical layer, okay, is like a physical connectivity. Okay, physical connectivity related, right? Same as like data link layer, network layer also connectivity and communication related only. Okay, means like a IP address, dealing with IP address, MAC address, basic physical connectivity part. Of course, the devices, networking devices, coming to the networking devices, hub, switches, router. So when I'm explaining these 3 routers, then also I told layer, it is as per OSI layer, it is layer 1, as per OSI it is layer 2, as per OSI layer 3 kind of stuff. So of course it is the example for physical layer is hub, data link layer is switch, network layer is router. So that's it is layer 1, layer 2, layer 3 devices. Okay, so this is the one of the reason that's why I always write from the application layer to physical layer is because top layers must be in a upper position, right? Okay. Next, middle one. So we forget about middle one, transport layer. Transport layer is a heart of OSI layer. It is also provide a end-to-end connectivity. So why it is a software or hardware part? It is also part of software layer only. It is also part of software only. But it is intermediate between a software and hardware layers part. It is also that's up to that point we'll leave it. Okay. So from here it is an explanation about a application layer and all. But I added actually these 2 parts comes under application layer only, but I have separated to tell about the port protocols and port numbers. Okay, so I will explain application layer onwards before going to that one. So we should discuss about protocols and their port numbers, kind of stuff. Listen very carefully, guys, because this topic again, so servers and service part also there. What is meaning of protocol? What is protocol? What is a protocol? In our my college days and all, people tell protocol is a set of rules. And okay, we written a set of rules in exam. Also, we written a set of rules. We got a marks. Okay, so once engineering completed, we started learning CCNA kind of stuff, and we started putting questions ourselves. So what is the meaning of this set of rules? In academies, they said what is a set of rules means when lecture come into the classroom, you have to stand up. So that is a set of rules. A police will sell you to right. So it's a set of rule. So that is a protocol. Yes, that is a protocol, not set. That is also maybe a set of rules. But in networking, it is different. In a networking, what is these rules or what is these protocols use? Protocols, using a protocol, the server and client understand what kind of service it is. What service it is. What is the user request? Okay. What is the request and what is the response? For understanding that, we require these protocols. For example, you are like you need a leave, right? So you need a in your college days or school days. So you have to take a 1-day leave. So what you will do, you send a request to the class teacher or a principal. So you need a 1 or 2 days leave to go to your hometown, right? Okay, so to whom you are asking? To your class teacher or a principal. What you are asking? Request for a leave, request for a leave for a 2 days or a yeah, that is right. So that is you put in a subject line. So why we are putting in a subject line? So whenever the principal see, so you see the first request like a subject line. So yes, this is the subject line, then matter, then to address, from address kind of stuff. Who is asking, to whom it is asking, who is asking, to whom is asking. Okay, so what is the subject, what is the paragraph? Same way, these protocols are like a subject only. So to what you are asking, you are asking, you are in a communication from client to server, you are sending a HTTP protocol. HTTP protocol, it means you are asking a web page. Okay, you are asking a web page. Please give me your web page. Your request is FTP request. It is either you want to upload or download a file. You are using SMTP. You want to send a mail. You are using POP3 or IMAP. You want to receive a mail. You use the NTP protocol. You want to synchronize the time between your client and server. Network time protocol. LDAP Kerberos is used for authentication, user authentication. Okay. Remote access protocol like SSH, TELNET, RDP, remote access request, right? So here it is a PCA is a client and server A is a server, which is a web server. Actually, it is a something like an example. It is a web server. So PCA is sending a HTTP request, and server is receive the HTTP request. Yes, is asking for a web page because it's a HTTP request. It send a response. PCA send a SMTP request. It means it's a mail request. Server A is a web server, not mail server, right? Server A is a web server, not a mail server. So what it will do, it drop the packet. I am not the web server, right? So it will drop the packet. It's not for me because I don't have that kind of mail services. So this is called a protocol set of rules. To understand, we use the protocols to make understand what is the request from the server to the client, from What is the request from the client to the server? Which type of communication it is? This also defines which type of communication it is. These are the different type of protocol, guys. There is a lot of protocols are there, almost like more than 1,000 protocols are there. I put only few protocols that is most regularly used protocols and frequently asked protocols also. Okay, so you can easily remember and based on your understanding. Okay, you have to group the protocol so that we can understand. Never try to remember with a port number, order, and a protocol like a 1, 2, 3, 4 kind of stuff. Don't do it. Okay, so I put this. And what is these port numbers? What is this port numbers? Port numbers are easily tell. It is a numerical representation of a protocol. A numerical representation means instead of HTTP I use 80. Instead of HTTPS I use 443. Okay. So what is the difference between HTTP and HTTPS also we'll see. Okay. So here is a list of protocols and port numbers, also very important. Please, once again, just I will tell these things. Okay. HTTP, sometimes abbreviation also try to get the abbreviation is always better to know it. Hypertext Transmission Protocol. Okay. The port number is 80. HTTPS is 443. It means it is a security is different. HTTP is a plain text type, means no encryption in HTTP. HTTPS encryption is there. It encrypt the web communication data. That's why we are all using HTTPS. Means whatever the data is here, it is stored in a remote Google server, right? I'm getting it from there to here, here to there. It is encrypted. So if anybody want to check this what data is transmitting, they don't understand. They don't understand because it's a encrypted. Some symbols it is showing. We cannot understand what is the data. Okay, your mail accounts, bank accounts, mail accounts, bank accounts, social media like Facebook, okay, Instagram, LinkedIn. These are all HTTPS only. Why HTTPS? What are the data inside these websites is encrypted while transmitting data. Even certain websites nowadays, most of the websites are HTTPS only. Okay, you want to build a website with HTTPS, you have to pay a little extra for this security. You want HTTP, no security. Very simple. HTTP, HTTPS depends upon sensitivity. S represent our SSL type also. Okay. FTP protocol, file transfer protocol for uploading and downloading protocol. There is a two port numbers are there 2021. SSH for a remote access. For example, I have a remote Linux server is there. I can access that Linux server from a PC using SSH protocol. Same goes for TELNET also. I have a remote device or a remote PC, remote system is there. I want to access from my PC through network. So I can able to give some commands. I can run some scripts, some controls I can do it. So that is using a TELNET. Again, both are same. SSH and TELNET both are for a remote access. Both are for a remote access command line interfaces. Command line interfaces only. Only difference is SSH is a remote access with encryption. It encrypts the data while it is transmitting and receiving. Okay, SSH secure shell. Port number 22, telnet is 23. RDP remote desktop protocol. For example, I have a my Windows server in the network or a Windows client in the network. Okay, Windows server or a Windows desktop in the network. I want to access that desktop environment from my PC. So I have to use RDP protocol. My request is RDP protocol. Port number is 3389. Of course, it is a encrypted, that's a big port numbers. Non-encrypted port numbers usually smaller. And that is also not correct, 100% not correct statement. Why? Because SSH is 22. It's encrypted state. By default, it is the protocol. By default, it is encryption. TELNET is different. SSH is different. Okay, build in different separate areas. SMTP, POP3, IMAP. So SMTP, POP3, IMAP. These three protocols are used for a mail communication. Used for a mail communication means email communication. So SMTP, simple mail transmission protocol. To send a mail, you want to send a mail, then we use SMTP. Send a mail to mail server. You want to retrieve a mail or you want to take a mail from the mail server, you can use POP3, Post Office Protocol version 3, or you can use IMAP version 4 protocol. Okay, so SMTP 25, POP3 110, IMAP 143. TFTP, FTP is different, TFTP is different. FTP to upload or download a file, but TFTP is for a remote configuration, means to download a remote configuration or to backup, to take the backup of a remote server or a remote device like a router, such as configuration, to either you can take a backup or you want to restore the backup. So usually we use this TFTP, trivial file transfer protocol. Port number is 69. Okay, DHCP, dynamic host configuration protocol. You are already having that idea. What is DHCP? What is DHCP? Dynamic host configuration protocol. Okay, what is the use of this DHCP? To assign an IP address to the client basis. Like for example, I have a laptop. I got an IP address from my DHCP. You have a mobile phone, you got IP address from the DHCP. Your laptop got an IP address from your Wi-Fi router, means your Wi-Fi router act like a DHCP server. So while taking an IP address from the DHCP or giving an IP address to the clients, in a both are there, right? So that's why it is two port numbers, 67, 68 port numbers are used. If you have a doubt, what is the use of 67 and what is the use of 68? So you can simply put a DHCP port numbers, then you can find it. Okay. So what is DHCP? To assign an IP address to the clients automatically. Okay, my laptop got an IP address from my Wi-Fi router, which is act like a DHCP server. I got it automatically. DNS give an IP address for a certain domain or a host to the client. Means, for example, DNS, domain name system. If you open google.com, so you will get a google.com IP address, right? You try to communicate with google.com, but you don't know the google.com IP address. So DNS server will give you google.com IP address. You want to communicate, you want to open a facebook.com, but you don't know the facebook.com IP address. You'll get it, facebook.com IP address. Okay. Okay, so who will give this IP address? DNS. So there is little confusion is there. So DHCP is giving IP address, DNS is also giving IP address. The difference is the DHCP is configuring IP address to your client, your PC. Okay, you are a DHCP client, so you will get a DHCP. You will get an IP address. Means you have an IP address. For example, last time people confused. I given one example. Guys, see, you have a mobile phone and your phone number. Okay, your phone number, that is yours. Your phone number having a phone number that is your phone number, right? Similarly, like I have a laptop, so my laptop having an IP address. Who is giving this IP address? DHCP. Next, for example, in your mobile, you have a contact list. In your mobile, you have a contact list, name and phone number. So those contact list numbers, not your numbers, right? Those contact numbers, not your number, someone's phone numbers. In a contact list, we have a someone's phone number. You may be your father, mother, sister, brother, or maybe your friends. Okay, like shopkeeper or any phone numbers are there. My phone number may be there. Okay, so your name and phone number will be there, right? So or maybe your Ruxana madam or Charan sir or Madhu sir phone numbers will be there. So what is the use of this phone number? Okay, sorry. What is this DNS here? Like you want to call to someone, you want to call to me, for example. So what you will do, you will open my contact number, right? You will open my name, you dial, call goes with my phone number only. So that is what DNS will do it. You open a google.com, you try to open a google.com, you don't know the google.com IP address, the DNS server will give you. Okay, DNS server will give you an IP address. The port number is 53. That's it. NTP, Network Time Protocol. So I am getting the date and time, right? So this date and time, I got it from a server. Which server it is? I will show you that one. Adjust date and time. I will show you from here easily. Click on internet time. Change settings. See, it is time.windows.com. Time.windows.com. This is a Microsoft server, one of the Microsoft time server it is. So I am getting synchronized my time with this website. With this, not website, it is a server. It maintaining the time based on my time zone. Based on my time zone, I am getting this time. Okay. So that is a NTP. It synchronizes the time as per the time server to client and server machines. NTP, Network Time Protocol. Kerberos and LDAP authentication purpose. Kerberos used in a Microsoft Active Directory environment. So Kerberos port number is 88, LDAP port number is 389. Authentication like a username, password verification kind of stuff. That is authentication. SNMP, Simple Network Management Protocol. Simple Network Management Protocol. So port number 161, 162. So what is this use of SNMP? For monitoring. So at the time of service desk also I told about monitoring, event management, alert management kind of stuff, right? So I have an infrastructure. I want to monitor this infrastructure from my system with a certain software. So what is this software will do it? It will send a SNMP traps. Sorry, the software receive SNMP traps from the remote devices like a servers, maybe storage devices, routers, switches. So what happens? So I can know the status of those devices or information about those devices. SNMP, Simple Network Management Protocol, 161, 162 port numbers. Not only these port numbers, guys, there is a lot of things are there. MySQL server, Oracle SQL server, different port numbers are there. Different type of communications, different ways of communication, means different way of servers, their protocols, port numbers are there. So depends upon different port numbers also there. I given this list of port numbers, which is mostly used port numbers. So compulsory, go through it, try to read it, and by heart it, whatever it is, you do it. Compulsory, guys, compulsory. Okay. So this is about protocols and port numbers. Now we will going to start with the application layer. Okay. So I will give you a very simple way. Try to remember like that. Application layer. So when already I told about this communication, right? So application layer is deal with your protocols and application part of your server and client. Means I'm open a website using my web browser, right? So my web browser is a client software. Web browser is a client application, web client. I have an Outlook to see the mails, to check the mails, or to compose the mails. I have an Outlook application. That is also client. That is a Outlook is a mail client software or mail client application. That is also comes under application layer. At server side, for example, you have a web server. So the web server, how it is become a web server by installing some application or a role. For example, Microsoft in Internet Information Service, like a IIS role. By installing Microsoft IIS role in the Microsoft system, it is become web server. For example, I have a Linux PC, I installed Apache HTTPD, then it is become web server. Or I install Tomcat, then it is become web server. I install MS Exchange in the Windows server, then it is become a mail server. Maybe I will install Zimbra to make it as a mail server. I install SSH to make it as a SSH server. I install a TELNET thing, then it is become a TELNET server. Okay, that is I will try to show you that is. Like a turn Windows features on or off. I'll try to open this. I want to make this one as a some TFTP client. I install this, I will become a TFTP client. Telnet client. So I will become a client, not a software server here. Okay. So like this. Oh, okay. Internet Information Service. If I install this Internet Information Service like this, then automatically my PC become web server. I install only FTP, then it is become FTP server. I install all the things. Okay, means I am a web server as well as a FTP server. Okay, so how you become a server? By installing certain role or a feature or by some package or an application, you become a server. What type of server? Web server, mail server, FTP server, a database server. So those are all applications. Those are server and based on that application. And at a client side, we have a web browsers, Outlook, mail communication, PuTTY applications, FileZilla kind of things. Okay, these are client side applications. So your application layer is deals with your protocols, port numbers, client applications, server applications, client to server request, server to client responses based on protocols. Okay, so these are all comes under application layer. What is example for application layer is easy to say web browser. Okay, Next is presentation layer, guys. What is this presentation layer do? What are the data you are transmitting from your PC to another? Okay, whatever the ways, it is a web-based communication or maybe a file FTP type or maybe just a ping command. Okay, so whatever it is, you're sending some data. So that's what it will do. It encode the data while you are sending. It encode the data. When you're receiving, it decode the data. So encoding means it will convert what are the form of your data. It can be a data in a HTML format or a text format, picture format, or a music format, or a maybe video format, right? So whatever it is, the format is converted into ASCII format, American Standard Code for Information Interchange. Okay, it convert into ASCII format because the ASCII format is direct hexadecimal format. Directly, it can convert into binary. Okay, so that is encoding. Decoding means ASCII format to normal format. Compress and decompress the data. So you have a data, you're sending and receiving a data, right? So while it is compress the data and send it. So the size of the data will be reduced. Encrypting and decrypting. For example, you are using HTTPS. So using SSL certificate, so you will encrypt the data while you are sending. You'll encrypt the data. While you're receiving, you decrypt the data. That's why you can able to see the matter on the screen, right? So encrypt and decryption. So this is a presentation having a direct role is encoding, decoding, compression, decompression, encryption, decryption. Next layer is a session layer. It create a session, maintain a session, and terminate a session. For example, I open this page. The request go to this w3schools.com, right? So this is my client and this is my server. Somewhere it is located, right? So when I'm sending a request itself, I create a session ID. Okay, so I'm sending a request to this web server. So it will create a session ID and the request will go and reach the server and I got a response, means transaction completed. You send a request and you got a response. Mostly what will happen, this session ID will be done, terminates. Till it will try to maintain the connection. Okay, so communication. So that is session layer window. So it create a session, maintain the session, and terminate the session. Next one is transport layer. It provide end-to-end connectivity. It segment the data. Transport layer having a segmenting. It means it take the data, we cut it into small pieces. Okay, so why we are dividing it? So while so why we are dividing, we'll see that while you are dividing it, we put a numbers and a sequencing order. Okay, we put a numbering and sequencing. Okay, what is the use? It is transport layer also do error correction. It means you send a 10 packets. So one of the packet is not received by destination. So we can able to send that packet part only. Okay. So what is the transport layer? It chop the data into small pieces called a segmenting, and also it is numbering and sequencing the data. For example, here it is, I have an example, hello, how are you? So 4 parts are there. One of the part is missed. For example, 3/4 R is missed. So the destination give the acknowledgement for hello, how you. It is not sending a acknowledgement for our 3/4 pack called R. This is only for understanding. I am giving this example. Okay. So source will send that 3/4 packet only Okay, so the destination received, then the word become hello, how you are. But what it will do, it will see the numbering, so it will rearrange it again at a destination. Okay. Otherwise, like why we should chop the data. So what will happen? Yeah, you want to send a packet called hello, how are you, and you send it. So at the destination, something is happened while it is traveling. Something like hello, how are you become who are you. Then the meaning will be changes, right? So what I will do, the client receives, means destination receive the data error, data got some error, data is corrupted, you drop the packet. So source don't receive a acknowledgement for the destination from the destination. The source think the something is happened with to data, again it is try to send it. Okay, so every time it is getting about till the destination got correct one, we have to send it. So what we have to do, better is chop the data, put it in a sequencing numbering on it. So then once the destination received it, so which destination knows which packet is missing already, it will tell to us, then we have to come. Multiplexing and demultiplexing of protocols. So we have a protocols that like just before we discuss different protocol, HTTP, HTTPS, FTP, TFTP, DHCP, DNS, SMTP, POP3, IMAP, SNMP. What is these protocols? These protocols, either it is TCP type or UDP type protocols. So TCP type protocol having a TCP type of properties. UDP type protocols will get a UDP way of communication. What is the TCP way of communication is acknowledgement based. You send a packet to destination, the destination received a packet and send an acknowledgement. Again, you will send another packet, then destination will send you a acknowledgement. If in case source doesn't receive acknowledgement from the destination, source think it is not delivered, so we have to send it again. Next, UDP type of protocol. So user datagram protocols. Okay, no acknowledgement kind of stuff. Source send a packet, destination either received or not, source don't know because no acknowledgement here. So source will keep sending a data, the acknowledgement, because of no acknowledgement. If any packet is not reached or any packet is down, so what you will do, so will be source don't know. That's why the UDP protocol is a non-reliable connectionless protocol. TCP is a reliable and connection oriented protocol. Some people will ask me like, sir, it is not some people, even interview question also there. So UDP is a connectionless, how it is will be connected. Okay, so when you say connectionless, we think it is a wireless. Connection oriented is a wide. Actually wrong on concept, guys. I'm using HTTP protocol. HTTP is TCP protocol. That data is going through my router only, right? It is a Wi-Fi router. So there is no wired and wireless connection. Connection oriented means two-way connectivity. You speak, I speak, you speak, I speak type of two-way communication. Connectionless, I am only speaking, only will be speak. So, connectionless protocol. They are not completed. So transport layer multiplex the TCP UDP protocols, means it all TCP type protocols into TCP multiplexing, all UDP into UDP multiplexing. Flow control and windowing means not always the same connection speed you will get it, right? Sometimes because of the port traffic, sometimes because of poor connectivity. So you may not get a correct flow controller. Windowing means backend transmission between source and destination. Okay, so it will flow controller warning. It will estimate how much data, how many packets the destination can able to receive. Based on that only it will send. PDO represent packet data unit. So data in any layer call you PDU. So what is the data outcome of this each layer is PDU. Okay, so in here for our regular data, so we are adding a TCP header. Is called a segment. TCP header is added to our PDU. Our data is called a segment. Okay. So all this TCP header is contains about a segmenting, numbering, sequencing protocols under TCP UD. This segment sent to the network layer. Just a minute, guys. Just relax. 1 minute. Okay. So I will complete this one. So network layer, data link layer, and physical layer. Okay. You want a TCP that is we will see later. TCP UDP references. Then I will go to other things. Next one is network layer. Just 1 minute. I will have some water. I think lot of people are sleeping. Guys are understanding. I'm just keep telling only. I'm not asking middle also. So do you understand this point or also? Somewhat understanding or completely out of order? Okay. Okay. So important is remember the 7 layers. Remember what is OSI and what is the 7 layers. Each layer one point, at least 1 or 2 points. Okay. That is enough. Like I will tell that one point kind of stuff, 1 or 2 point kind of stuff. Here it is. First, we'll complete all layers. Network layer. Network layer is dealing with routed protocols and routing protocols. What is routed protocol? What is routing protocols? Okay. Routed protocols are about a IP addresses kind of stuff. IP address, IPv4 or IPv6 or SPX or kind of stuff. So it is all about a addressing. So I use only IP address part only. I don't use that IPX, SPX, ABLTAG kind of. So I never used it. Usually say maybe once in a lifetime, but perfectly never use it. Okay, never learn that kind of stuff. Okay, so we don't mind about it, so how it is. We just only to spell on part. Okay, so routed protocols means about IP address. Routing protocols means how to reach the destination will be is show us like tell us by routing protocols only, like RIP, EIGRP, OSPF, okay, BGP, ISIS protocols are routing protocols. Routed protocols are IP addresses. So in generally, network header is added to the segment. The segment came from the transport layer. The packet. So network header is added to the segment. It is become a packet. So originally we use I send a packet, I received a packet kind of stuff. Okay, so we use the packet word for every place. That packet means it is a contains a network header to the segment. It is a packet on that part only. It is packet. What is this network header contains? It's about a source IP address and a destination IP address. So when you are communicating, like you have to send to address and from address, right? So like a source IP is from address, destination IP is to address. Source IP, destination IP address. Source IP and destination IP. So network header contains source IP, destination IP is added to segment, then it is become packet. So packet contains source IP, destination IP and segment. Of course, that packet will send to data link layer. Data link layer is divided into two layers. One is LLC, another one is MAC layer. You know MAC already, but we'll go to the first LLC, that is a logical link control, which is actually having a WAN protocols. It actually deals with the WAN protocols. That too, data link layer is a pure hardware part. Means your NIC switches are comes under a data link layer. Means actually NIC is a combination of data link layer and physical layer, because we use TCP IP, right? So the in a TCP IP, data link layer and physical layer combined called a network access layer. So that is important, right? So your NIC. Of course, we'll come back. This what is this logical link control? Is all about a WAN connectivity. Like you have a two routers are there. You want to connect like you want to connect it to the WAN. So we have to use certain protocols. Okay, like either it is PPP, point-to-point protocol, SDLC, frame relay, MPLS, PPP OE, point-to-point protocol over Ethernet. Okay, that is Ethernet based WAN protocol, but it is PPP is a serial communication. That serial part is there. So whatever it is, guys, LLC, link logical link control, dealing with the WAN protocol. Okay, PPP, SDLC, frame relay, MPLS, this all comes under WAN protocols. Next layer is a MAC layer. So what is a MAC layer? Media access control. In a MAC layer, actually in a data link layer, it adds data header and data tail to the packet. What is this data header? It is source MAC address, destination MAC address, the packet plus CRC. The whole combination, it is called a frame. My PDU is a frame now. What is this CRC? Cyclic redundancy check. It is used to check for errors. For example, I transmit a packet from source to destination. What destination will do it? Destination use this CRC, use this CRC. Already I am sending data along with the CRC value. So destination check the packet, received a PDU and see the CRC. Using CRC, it is trying to calculate, means it is try to check the data is good or corrupted. If it is corrupted, it drop the packet. We don't receive anything. So CRC is used to check the data, whether data is good or corrupted. Okay, so I click redundancy check for error checking. Source MAC address, destination MAC address is added to your packet, and CRC, it become frame. Then frame is sent to the physical layer. This frame is converted into bit stream. Bit stream means 0 ones, right? So already frame, it is in totally anyway, it is ASCII format only, but whatever it is, the content of frame, the frame is converted into bit stream, zeros and ones kind of stuff. Now, based on your physical connectivity, so you may use Ethernet or Wi-Fi kind of stuff, or maybe a fiber channel kind of stuff. Based on your physical connectivity, the bit stream will be converted into the required signal type. For example, the bit stream is converted into electrical signal, or maybe a radio signal, or a light wave, based on your physical connectivity. So this is the physical layer. Okay guys, 7 layers are completed in a single part. Actually, I will take 2 days. We know very golden days. Now I'm taking only 1 day, 2 classes, but I have taken 1 class only. So again guys, 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Application layer dealing with your protocols, port numbers, your client application, server side applications. So where you put a protocol kind of stuff in application only, that's why it is. I combine this application and protocols and port numbers kind of stuff. Like you want to send a request like a HTTP call and something, right? So you are using already HTTP, means you are using a protocol. You are using HTTP protocol in web browser, FTP protocol in some other applications, SSH protocol in some terminal array application, right? So SMTP protocol you use in a Outlook kind of application. It is like that. Okay, the protocols, your application like a client side application and server side applications comes under application layer. Presentation layer is having mainly 3 duties: encoding, decoding, compress, decompress, encrypt, de-encrypt the data. The session layer is to create a session, means when you are sending a request, you create a session layer, session ID. Okay, once you are received a response from the server, completed, your transmission is completed, you send, you received, it means session is completed. Okay, till the session completed, it will maintain the session. Any interruption is occur in this session, like a disconnect of network kind of stuff, the session will be automatically terminated. Very simple guys. When you are sending a request at client, the session will be created. At server also, when it is server is sending a to that one, like source to destination, you are sending, session ID will be created, and it maintain and terminate once it is fulfilled. Transport layer provide end-to-end connectivity. We segment the data. We put a numbering and sequencing for to make at a easy to construct a destination, and also it is used for error correction. We correct an error. How we can correct an error here? So whenever the destination is not received a packet, so what we will do it? So destination not sending any acknowledgement to the server. So we will understand destination packet is got something problem. It is not received or corrupted. So we can able to send it again. Only that packet only. and at a destination, it can easily rearrange based on the numbering and sequencing part. So transport layer provide end-to-end connectivity. Segment the data means cut the data into small pieces. Sequencing numbering to make sure the data arranged in a proper order and is used for error correction. Pause. Okay. Multiplexing and demultiplexing of TCP type and UDP type protocols. Flow control, windowing. Okay. The PDU means the data from transport layer, means outcome of the transport layer is segment. The segment sent to the network layer. At network layer, it add a source IP and destination IP routing protocols routing information. That's it. Data link layer having two layers. Logical link control, meaning okay, that is contains of WAN protocols. MAC address. Okay. Media access control. Data link layer having another layer is media access control layer, MAC layer. So in that one, the source MAC ID, destination MAC ID is and the CRC is going to be added to your packet. Then it become frame. The CRC, cyclic redundancy check, use it to for error correcting, error checking. These frames sent to the physical layer depends upon the physical layer. The frame is converted into bit stream. Based on your physical connectivity, the bit stream is converted into different signal type. Means if you are using Ethernet, UTP, STP cabling, that is a electrical signal. Wi-Fi, so radio signal type. Wireless, right? So fiber channel, light waves. One more important is TCP UDP difference. Transmission control protocol, user datagram protocol. TCP is a acknowledgement based protocol. UDP is a no acknowledgement kind of transmission. So whenever the destination received a packet, it will returns the acknowledgement to the source. Source understand destination received a packet. Okay. If in case destination not received a packet, so then it is either it may drop the packet. So what happened? You have to send it again. So that's why it is called a connection oriented protocol, reliable protocol. Example of TCP type protocols are HTTP, FTP, SMTP kind of stuff. UDP protocols. Whenever you send a protocol to the destination never returns any acknowledgements. Okay. If and it will keep even one. Okay, even a packet is not received in a destination, UDP type protocols don't understand. It will keep sending the data. It is connectionless because of we don't know whether destination received a packet or not. Unreliable also. Network layer adds the network source IP, destination IP to the segment. It become packet. The packet is where I'm going. Yeah, that's it. That's about your OSI layer. Yes, when you are communicating from one PC to another PC, PCA to PCB. Application layer first. So you open a website. You open a website in your browser. Application layer. HTTP protocol website you are open in a application. Then presentation. It will encode the data, compress the data, and encrypt the data. Session layer will create a session ID added to our data. Then it is go to the segmenting part in a transport layer. Segmenting TCP, UDP, multiplexing, flow control kind of stuff happens, right? Network layer, it adds a source IP, destination IP to our packet, and data link layer, it adds it adds source MAC address, destination MAC address, to your packet and CRC, then it will become frame. The frame is converted into bit stream, and for example, you are connected a regular connection like a electrical signal. So we reach another BCB physical layer. See, top to bottom and bottom to top, while you are sending application to physical layer, when you are receiving physical layer to application. So layer wise troubleshooting also I will tell after a small break, but see, it is physical layer received it. Now the bit stream will be converted into the frame, then data link layer check the source and destination MAC address, and it saves the source MAC address against source IP address, like a PCA's MAC address and PCA IP address will be mapped together. Okay, so data link layer. So source MAC address, destination MAC address, and CRC. So first of all, it uses CRC to check the packet, whether that packet is what are the PD is, it is good or corrupted. So if it is good, then it will go to network layer and it verify the source IP and destination IP. And destination IP is same IP as a PCB, then it will accept the packet. Okay. Segmenting. Okay, remaining is goes up like it will verify one by one like a source IP, destination IP removed. Segmenting is there, so the segment is go to the transport layer. You check the sequence and order. So once all packets are came, so it will arrange properly. Okay, like that. Session ID will verify the session. Session layer will verify the session ID and create a new session for transmitting data. Presentation layer. So at first it is encoded and it is decoded here. Compressed, here it is decompressed, there it is encrypted, it is de-encrypted. Okay, again it go to the application layer. Application part of layer will understand the request and send it. Okay guys, this is about your OSI layer. OSI TCP comparison, OSI layer based troubleshooting is also there, but I will take after break. But yeah, these are the OSI TCP or a DoD model comparison. The data link layer and physical layer is a network access layer. Network layer, here there is an internet layer. The transport layer is a transport layer. Application presentation session is combinedly application layer. Only 4 layers are there: application, transport, internet, and network access. So this is the comparison. Transport is transport, network become internet, but here it is data link, and physical layer is a network access. Okay. So so next part we'll see how to troubleshoot using OSI layer and also ping troubleshooting. We'll see. Otherwise, we'll go to IP address part. Okay. Guys, take a break.